Hello everyone, welcome back to Skill Talk. In today's video, we will be discussing the next topic, that is the principles of vibration. So this is a very important topic because it's known as the foundation of the vibration analysis. So here we will be covering some terms, that is like simple harmonic motion, which is also known as SHM, and we will be covering what is amplitude, frequency, what is period, what is displacement, velocity and acceleration. Okay, in simple and the practical term. So by the end of the video you will be clearly understand what these terms mean and how they connect to the real machine vibration. So let's start with the first basic concept of the simple harmonic motion, or also known as the SHM. So in the simplest form of vibration, let's say there is a moving object that is swing back and forth in a smooth and the repetitive manner around its central position. So let's say that imagine a spring with a weight attached. So if you pull it down and release it, so what will happen, that it will move up and down continuously. So this logic is known as the SHM, or this process is known as a simple harmonic motion. So the motion will repeat itself after a fixed interval of time and follows a simple sine wave pattern. So in real machine, normally we will never get such kind of a very smooth sine waveform, or known as a simple harmonic motion, because in the real machines they vibrates very differently, and it's not always you will be getting a very smooth sine waveform. But why we are learning this concept? Because this concept helps us to mathematically describe that how normally machine moves and how we can measure the vibration in the terms of amplitude, frequency and the period, right? So let's start our next topic, that what is amplitude. So now the first property of the vibration is known as the amplitude, and amplitude is simply the maximum distance that the vibrating object moves from its center position, or you can say the mean position. So in simple terms we can tell us that how strong, or you can say the how large the vibration is, or in another very simple way we can say that the amplitude describes the severity of the problem, right? So if you see a sine waveform, let's say the height from the center line to the top is known as the amplitude, and the higher amplitude, that means this machine is having the high vibration, or you can say the vibration of this machine is very critical. In the same way, if the amplitude is low, that means this machine is having the low vibration and machine is smooth and okay to run further. So the unit of this amplitude will depends on what type of parameter that you are measuring of the machine. Let's say if you are measuring the displacement, then definitely the units will be in microns or maybe the mils. If you are measuring the vibration in acceleration, then it can be in mm per second square, or it can be in g, that is acceleration due to gravity, right? In same way, if you are measuring the velocity, so the vibration will be, you can measure in the mm per second or inch per second, right? So it depends on the what kind of parameter that you are measuring. Now let's move to the next important term, that is known as the frequency. So what is this frequency tells us? The frequency tells us about that how many complete vibration cycles that has been completed in 1 second. Okay, so normally it defines that how fast the object is moving. In the normal term of the vibration analyst, frequency help us to identify the source of the vibration, right? So it helps us to confirm that from which location or which part of the machine this vibration is coming. So let's take one example of this frequency. So let's say if a motor shaft completes 10 vibration cycles in 1 second, so what will be the frequency? It's very simple, the frequency will be 10 hertz. So what is the unit of this frequency? Either you can just use hertz, or also you can use as CPS. So don't get confused cycles per sec between cycles per second and the cycle per minute. Okay, so cycles per minute, that means also known as the RPM of your machine, and cycles per second is nothing but it's equals to the hertz, that how many cycles of that machine has completed in 1 second. So that is known as the hertz, right? So different faults in the machine create vibration at different frequencies. So that's how we identify what's wrong in going on in the machine using this vibration analysis technique. Now the third important terminology is the period, right? So what is this period? Period, you just simply say it's an opposite of the frequency. So period is just the time taken for one complete vibration cycle. That means how much time taken by the machine to complete only its first cycle, or you can say the one cycle. So let's say if a vibration has a if we are having a machine is running at the frequency of 10 hertz, so its period will be 1 by 10. So if you will divide 1 by 10, so it will be 0.1 seconds. Okay, so overall you can say the formula for time period is it's equals to 1 by f. So where t is equals to pl, that will be in seconds, and the frequency will be in hertz. Now let's discuss about the displacement, velocity and acceleration. Remember we just now discussed about the amplitude. So amplitude can be measured in three forms, that is either the displacement, velocity or acceleration. So these are the three parameters that are extremely important, because what they do, they define the vibration in different ways depending on the machine speed and fault type. So let's understand them one by one. Okay, first we will go with the displacement. So what is the displacement? Displacement is the total movement from one point to another. Okay, from one end to another. So displacement is a total distance that a point on the machine moves from its mean position during its vibration. So it represents that how far a part actually moves physically from one end to another end. Understand? So displacement is most important for low frequencies, or you can say the high amplitude vibrations like unbalanced. So most of the time you will see that the vibration analysts are using the displacement for the machines which are running at, and at a low rpm of, let's say, of 200 rpm or 300 rpm. So now how we can measure the displacement? So this displacement can be measured with the either in micrometers, or you can say the microns, or it can be also measured in the mils, right? So now next we will move to the next parameter, that is known as the velocity. This is the very common parameter that is used by the vibration analysts. So now what is this velocity? So velocity tells us that how fast the vibrating part is moving, or you can say that how fast the machine is vibrating, right? And how much far. Okay, so it is simply, you can say it's a kind of a rate of change of displacement, right? So this parameter is oftenly used for a general purpose vibration monitoring because it correlates best with the machine health. And we measure this velocity in mm per second. It's known as the millimeters per second, or it can also be measured in inch per second. So also this typically vibration meters, you have seen the normal vibration meters, they always display the readings in mostly in velocity. Now move to the next important term, that is known as the acceleration. So what is this acceleration? Acceleration tells us that how quickly the velocity is changing, right? It represents the force or the energy behind the vibration. So acceleration is the most useful for detecting the high frequency faults, especially you can say the gear issues, or the the bearing fault issues, and also some kind of some of the electrical issues. So normally this acceleration is measured in meter per second square, or also it can be measured in the g, that is the acceleration due to gravity. So I think that 1 g is equals to 9.81 meter per second square. So overall what the thing is that depending on the type of the machine and the fault type, let's say low frequency faults, that can be, for that you can use the displacement. Okay, if you are looking after medium frequency faults, then you can use the velocity, and if you are looking for some kind of a bearing faults or the gear defects and all the stuff, that is the high frequency faults, then you can go with the acceleration. Okay, so now let's do one thing. Let's take one real life example, so that it will be very easy for you guys to correlate whatever we have learned till now in this video. So let's take a practical example. Let's say we are monitoring a large industrial fan, and if it's let's say it's having a slightly unbalanced issue, right? So what you will notice, that you will be noticing a large physical movement. So that means large physical movement means that is having the high displacement. Okay, so the high displacement but the frequency is low, because let's say that you are monitoring any kind of a separator or any kind of a fan which is having the speed of 500 or 400, right? So what will measure, what parameter that you will be selecting here to measure the amplitude of the vibration is the displacement. Why? Because the frequency is low, or you can say the RPM is low. Now let's take another example. If let's say the bearing is having some kind of a issue in this fan, now what you will do? Now in this case you will be using the higher frequencies, that is the acceleration. Why? Because the movement is very small. If the bearing is having any kind of a issue, that will hardly allow the movement of the fan. So definitely in this case you will be using the acceleration, which is focusing on the higher frequency faults. So that's the reason that why vibration experts always look at all three parameters, that is the displacement, velocity and acceleration, to get the full picture of a machine. So all three parameters are very much important. So let's summarize this our video, that what we have learned in this video. So what first we have discussed what is SHM, that is the simple harmonic motion. We have learned about what is amplitude, what is frequency, and what is the period, and what are their relation and why they are important in this vibration world. And last we have learned about the parameters of the amplitude, that is that how, in what form we can measure the vibration, that is the displacement, velocity, and acceleration, and what are their units, and how these three, that is displacement, velocity, and acceleration, plays their different role based on the RPM or based on the frequency, right? So in next video we will be discussing that, we'll be taking some practical examples, and we will be seeing that how practically we can use all these principles in our real life. Okay, so thank you guys for being with the Skill Talk. Until then, please keep learning and keep growing, and we will meet you in the next video.